I'm happy to say our order from Just Radios has arrived. It only took 13 days, which is very good out of Canada. You know, considering I ordered something else from another outfit on the 7th of January and I still haven't received it. Good job on shipping time by Just Radios. Now what I'm going to do is extract the parts out of the bag that need to go in this parts bag, which is what we will be using to rewire the radio. And what's left will go into stock. So let's get that done. Well, there we go, folks. All the parts are all together, and that is one more step completed. I hope you young folks are beginning to realize a little something, that, you know, there is a method to this madness. We just don't jump in, start ripping wires, start changing, and then look around and, you know, try to figure out what just happened. We don't want that, you know. Get everything. It's called getting your ducks in a row. This time it's going to be a fairly short video. There's just a couple of things I want to cover, and we'll start out with this right here. These are the way tube socket pins are normally laid out. This is looking at the bottom of the tube socket, and you know, the tube would be on the other side for all of our newbie friends if you're not used to this, but you're looking at the bottom of the tube socket just as if you were looking into the bottom of the chassis, okay? Alright, and what we have here is a 4-prong tube. We have, you know, your 6 and your octal, which is 8, 7, and 9. Now the way these things are numbered, you can see the 2 large pins on a 4-prong socket. That's the key right there. Go to your left, starting with number 1, 2, 3, 4. Now down here, you again have a space, okay? Right there. And again, you go clockwise, 1 all the way through to 7. That's the key. That's space between there. Over here, we have a key that's on the, it's actually a little slot in the socket itself. And there's a key on the tube that fits in that slot, on the tube base. And where that key is, that is the same as the space. Okay, over here and over here. You go clockwise all the way around to pin 8. On the 6-prong tube, we again have 2 large pins. Now over here I said 2 large pins. You'll notice that, come on camera, focus up. You'll notice that 2 of the pins are larger than the other 2, okay? Between the 2 large pins on the bottom of the tube socket, the 2 large holes actually, and the pins on the bottom of the tube, of course, will be larger to fit those holes. Same thing over here, a couple of large holes compared to the rest of them, which are tiny. And again, that is the key. And last but not least is your 9-pin miniature tube, which again has a space, and between the space we count clockwise all the way around to number 9. Now that, I got this off the internet. You can find this, you know. These are just your standard tube sockets that you would find in the bottom of you know, most gear. Let's go to our own chassis now and take a look and see what we've got. Let me zero in on it. I want to get this thing out of the way first of all. Let's take a look at these sockets right here. Well, they don't seem, this socket doesn't seem to match up with any of these. What the heck kind of a socket is that? I don't see any comparison really. How about that? These are 5-pin. I don't even show a 5-pin on here. Well, keep in mind, you know, these are sockets that go all the way back to 1931, which is the date of this radio. So what? This radio is 85 years old? Well, you know, it's really, radio was still in its infancy, believe it or not, when this radio was made. It was barely out of the 20s, and it was at the height of the Great Depression. The Great Depression. And of course they were still learning how to do things. Look at the way this thing is. That's really interesting. The tube pins fit down through these holes right here from the other side. You know, whereas the newer ones are different. The holes just go straight through the socket, and they don't have these. It's basically a clip is what it is, and then the wire attaches The wire's attached to the other side. So how do we figure out what pin is what on this thing? Well, we do have a space here. See? Space here. Look at the distance between this one over here and here. It's quite a bit of space there. So using the logic that we have on these here, that would tell me that this would be going clockwise. It'd be 1, 2, 3, 4, 5. Well, I'd say we've got that pretty well ciphered out. Now let's go ahead and follow a wire out. Now in the last video I said we would start in the middle. Oh, this here looks like the middle tube to me. We've got 2 over here. We've got 2 over here. Let's start right here in the middle. Let's pick up with, let's pick a pin number. Let's pick, I'll tell you what, let's pick number 3. There's a nice easy one right there. And it comes down. Pin number 3 has a wire attached to it. It comes down. We're not going to go too much below that. I want to kind of keep it up in this area because we're just starting out. You know, we want to follow this stuff. So it comes down, comes across, comes up, goes to pin 3 on this 35 too. Pin 3 on a 35, over to pin 3 on a 35. There it is right there. Then it comes down again, and it comes across, and it comes up to this 35 and hooks to this pin 3. Well, this ought to be pretty easy. And there's even one coming off of there that goes down into a coil, which is the oscillator coil, right there. So the RF tube, pin 3, goes down into the oscillator coil. The rest hook to pin 3, to pin 3, and then of course we have some that come down over here, goes into the field coil. We're not going to worry about them right now. Let's just go ahead and make sure that these wires are connected as you see here in the schematic, okay? You'll remember in the last video we found out that this was a 35, this was a 35, this was a 35, and this was the 27, okay? So pin 3 of each of these tubes should have a wire going from one pin 3 to the other pin 3 to the other pin 3. Don't worry about any other wires right now. We're just going to make sure, turn this light off here and turn it around this way where it's not so bright. We just want to make sure that pin 3 goes over to pin 3, goes over to pin 3, and then we'll take care of this business down into the oscillator after we verify that those 3 connections are made. So let's go to pin 3 on the top 35. Alright, now remember, let me zero in there. I'm glad we figured out these tubes a little earlier than we thought. Get these babies taken care of. Get these wires out of my way. Boy, there's stuff everywhere here. Alright, there again, here's our space, our long space between these two. So this would be pin 1, pin 2, and pin 3. Let me get this wire out of the way, it's driving me nuts. Okay, pin 1, 2, and 3. Pin 3. Well, pin 3 is connected to a capacitor. What the heck is that doing there? 1, 2, 3. It's also connected to a wire. It's connected to 2 wires. One goes up into the antenna coil. Pin 3 goes up into the antenna coil. Let's see where the other wire goes. Comes down, goes to ground. You wiggle that, make sure. What the heck is going on here? We got pin 3 here. We got 1, 2, 3. Up to the coil, over to ground. Something's not right. Something's not right. They're supposed to, pin 3 is supposed to go down to pin 3 on this one. It's supposed to go down to pin 3 on this one. And already we've run into a problem. Oh, well, I'm kind of glad this happened, guys, because guess what? I'm going to beat you to death with detail. Oh, I love it. I love it. I love it. When I started this video series, I told you I was going to give you overkill detail, which involves logic. You've got to use logic. If you're not good at logic, if you're not good at looking at something and saying, well, something's screwed up here, I need to back up and start again. If you can't do that, then you need to find another hobby, okay? Because this one will kick your butt every time. Well, what's going on here? Pin 3 is supposed to go to there, but it's not. It's going to ground. It's going to ground. It's also going into the antenna coil. Well, that can't be right. That can't be right. Pin 3 does not go into the antenna coil. All right, let's see if we can find a length of wire on one of these pins that goes from 135 to the second one. We're not even going to worry about the third one. Let's just find something here that goes to here. All right, let's start up here with the RF tube at the top. We have this wire here, goes up out of there. Well, that's not the pin I'm looking for. This is not the pin I'm looking for because that would be pin 1, 2, 3, 4, 5. No, that would be 1, 2, 3, 4, 5. Something's not right here. I don't understand this. Okay, here we go. Let's use a little. First of all, let's go ahead and just find a wire that runs between the two tubes. I don't see any here. Now here's one over here. It's a black wire. Now here's one here that runs down to this pin on this tube. Let's see if it goes any further. We come out. We come out. We come out. Well, son of a gun. There's one running to the other. Is that loose or soldered? That's soldered right there to the other 35. Well, here's the pin. A pin is connected, a pin is connected, and a pin is connected. All 35, all three 35s. Let's keep following it down. Come on down. This is it right here. You bring it on down. Bring it on down. Let's get this junk out of the way. And it goes into. Son of a gun, it goes into the oscillator coil. It's connected right there to that terminal on the oscillator coil. Look at that. 3 35s connected together, and then a wire from one of the 35s over to the oscillator coil. Goes up into the oscillator coil up on the other side of the chassis. Let's go back to our schematic. Alright, here is pin 3. Over to this 35, over to this 35. Then it stops right there at the top part of the schematic. Then it comes over and it goes down into the oscillator coil. We just found that wire. That's exactly what that is. All right. However, it shows it as being on pin 2. Pin 2 there. And this would be pin 1. Pin 2 there. Pin 1, pin 2 there, and then all the way on down up into the coil. Why is it a pin 2 on the socket, but yet pin 3 on the schematic? And I know those are right because I checked them on the computer, and I also checked them in my tube manual. Pin 3 is the one that's supposed to be doing that, but yet it's pin 2 over here. Well, I'll tell you why that is. Are you ready? It's because this is not pin 2. It's actually pin 3. And this coming up here, this is pin 3, not pin 2. And this up here, going from here to here, this is not pin 3. This is pin 2. And then, of course, it runs down into the coil. Well, what am I saying here? I'm saying that this space here, it's not, the rule of the space does not apply like it does in these sockets. It applies differently in the old tube sockets that are 85 years old. Logic, my people, logic. You must use logic and common sense. So if this is number 3, no, I'm sorry, let's go up here to this one. If this is number 3, then this must be number 2. This must be number 1. This is number 1, not this one. Totally different from what was on this tube socket paper. Now it makes sense. Pin number 3 goes up to pin number 1, 2, 3, up to pin number here 1, 2, 3. All right. No, now we have a whole different perspective on this thing. Now we know the tube pins are different from this kind of stuff. We can get rid of this. Yeah. All right. Now the schematic takes on a whole new look. So what are we going to do next? I'm going to show you. The next part of this little ordeal we're going through here right now involves this orange felt tip pen, but of course you can use any color you want, you know, green, blue, orange, yellow, I don't care. We just checked out these tubes and found that all of the pin 3s of the 335s are connected together. So we're going to go ahead and show that on our little schematic. Just like so. And we also discovered that coming off of the RF 35 tube, it went down into the coil, and it was connected to the coil. So we'll go ahead and show that right there. Let me get a little wider. There we go. All right, look at there. Man, we are already on a roll, okay? That's what we're going to do. Now, the object of this whole game is to check every single wire out, and highlight every single wire to make sure it's connected properly. If it's not, we're going to reconnect. We're going to disconnect and reconnect it properly. If the wire is bad, we're going to yank it out of there and we're going to put a new one in its place. Color the lines, people. Stay on the lines. That's what it's all about. Okay, last thing I'm going to talk to you about coming up. Are we going to change out every single wire in this chassis? Are we going to remove every single wire? Well, that'd be stupid when you think about it. You know, the whole idea of never picking up a chassis that's totally been gutted is that, you know, not only can you see some of the parts that it needs, some oddball stuff. I can't wait to open that box up. Anyway, some of these wires are perfect. There's not a thing wrong with them. Why would I want to disturb or possibly destroy an 80-year-old tube socket just to change out a wire? If the one that's in there is already good. Now this one right here, eventually we will get around to, that'll be pin 2. See, that one's been messed with. Somebody has messed with that. Let me get around there where I can get a better look at it. Show it. See how somebody's messed with that one. They've unsoldered it, and then when they resoldered it back up, they did a crappy job. Look at the length of that lead right there. That's got to be fixed. But the rest of these are all, look at there. There's the original flux from the factory. Okay, this is pin 1, pin 2, pin 3. These wires are all good. There's nothing wrong with them. Let's leave them there. Now, as we need to change them, we will, like I said, okay? All right, last item. Last item, and then we'll call this baby quits. Someone said, what about color coding? You know, aren't you going to make, you know, the filaments a certain color coding and this and that? Let me ask you something. You see any color-coded wire in that chassis? All I see is white. And there's a reason for that. These 1930 radios, especially this one right here, is from the Great Depression. Many radio manufacturers were desperately trying to cut costs in order to keep selling their radios. Matter of fact, Philco made what they called a Junior. I think it was called a Philco Junior, which was only like 4 tubes. And it was a smaller radio. You can look it up on the internet. I think it's called a Philco Junior. I've never seen one personally. I've seen pictures of them. Anyway, that radio sold for like, what, $19.95? Something like that, you know. They had to do what they had to do to keep business rocking and rolling. So wires, whether, you know, all the same color? Yes. Why? To cut costs. They put any wire in there they could when the chips were down, okay? So are we going to go ahead and worry about the color coding, you know, whether or not this color is right, that color is right? No. I'm going to use white all the way through it, just like they did right here. What the heck? And for the heater wire, let me see if I can get this lamp over here. It looks to me like the heater wire. Now, the heater wire on the schematic, I didn't want to get into this, but I'm going to might as well do it now. The heaters are pin 1 and pin 5. pin 1 and pin 5, pin 1 and pin 5, pin 1 and pin 5. Okay, same over here, and they all come from. These are labeled A. See right here, it says you've got the letter A right there. Got the letter A right there. Got the letter A right there. And the letter A right there. These two leads are A. That means they go down here and connect right here to A, okay, on the primary. And so 1 and 5 are my keys for that. So let's take a look at this now. Let me get this lamp out of the way. Let's take a look at this real quick like, and then we'll call this thing out. I got to do one more thing. It's always one more thing. It's always one more thing. Pin 1, 2, 3, 4, 5. Pin 1 and 5, and pin 1 and 5, and pin 1 and 5, and pin 1 and 5 are your heater wires. And one side hooks to ground. And let's zoom in here a little bit. And what do we see there? Yep. Black wires coming down from the upper tubes connected to pin 1 and 5, just like pin 3 was, okay? There we go. We come on down here. So we know that they also look pretty good too, but we're going to double check those later on, okay? I just wanted to kind of show you what we got. That we now, since we now know that this is pin 1 for sure, that would make that one pin 5, and sure enough, it is. They are the heater. They are the heater contact, the heater terminals for the tubes. Okay, so that gives us like what, double verification that our numbering system is correct. All right, let's take a look at. Incidentally, I'm going to go ahead and use green. I was going to use green for the heaters, but it looks to me like those wires are perfect. I don't see any problem with them at all as far as being soldered. They've never been messed with, but we'll see later on. Color coding of wires. Since the subject was brought up, I decided to go ahead and look it up. Here's a little something you might want to write down. You can go back through and write it down. The wires in the chassis are different than the wires. I mean, the color of the wires in the chassis for the standard colors that were adopted by the radio manufacturers of America way back then, the RMA. The color of the wires inside the chassis were different from the color of the wires coming out of the transformers. You know, there were standard colors for the transformers that the RMA accepted, and standard colors for the chassis. Here we go. Now it says here that your black was for ground and grounded elements. Brown was for the heaters or the filaments. Red was for the power supply or B+. B+. Orange, screen grids. Yellow was the cathodes. Green was the control grids. Blue was the plates. Violet was not used. Gray was AC power lines, or that stuff doesn't apply. It's all right there. By the way, you can find this by going just doing a search for Antique Radio Forum, RMA standard color codes for chassis wiring. Okay, it'll all be right there. The colors coming out of the transformers. Now these are pretty standard. These are pretty standard. Even your old transformers had the correct colors. At least the ones I've found. There may have been some variances like Atwater Kent. They had their own way of doing things. And what we had is black were the primary wires. This is the transformer, not the chassis. Red was the secondary, or used for the B+ voltage. Red with the yellow tracer. In other words, a yellow. It was all yellow. It was all red with a yellow mixed in there. As they called it, the yellow tracer. Was the center tap for the B+. On your full wave rectifier windings. Green or brown was the heater voltage for all the tubes. Yellow was the filament voltage for the rectifier tube, often a different voltage than the other tubes. That's correct. Often you'll find that 5 volts is your rectifier filament voltage. All the rest are like 6.3 or whatever the case may be. And these are the colors you might want to write down if you ever have to rewire your transformer. This is what comes out of the transformer. But of course, once it gets hooked into the chassis, if you really, really want to follow the color codes, which I don't intend to do for this radio, I'm just going to go with what they had there originally. This is what you'll find in the chassis. I'll bet by the time I get done editing this stupid video, it's going to be 35 minutes long. And I was kind of hoping to do something about 15 to 18 minutes. Well, that's it until next time. Next time we'll do a little more wire tracing and hopefully a little more coloring in with this here pen. Until then, I hope you learned something, guys. If all you learned tonight was that the older tube sockets are a little bit different than what these newer ones are as far as numbering systems go, and you know how to figure out which is which. If you learned that, then you did good. Until next time, this is John.